Hello, I'm David Frise, Chief Executive of BESA. Welcome to Behind the Built Environment, the podcast where I delve into the major issues facing our industry through in-depth conversations with key industry leaders. Join us as we explore the trends, challenges and innovations shaping the future of the built environment. Today, in recognition of World Refrigeration Day, we're spotlighting the often unsung role of refrigeration in our modern world. And I'm delighted to be joined by one of the UK's leading experts in the field, Dr Catarina Marques. Welcome, Catarina.
Thank you, David.
So Catarina brings over 15 years of experience at the cutting edge of refrigeration engineering, with a career spanning food service, cooling, net zero innovation and integrated energy systems. She holds a PhD in refrigeration, a degree in food science and engineering. Her leadership has shaped major initiatives like the TICR project, a landmark government-backed programme investigating how we decarbonise refrigeration across transport, industry and commercial sectors. She was the project manager for Green Skies, which links low-carbon heating, cooling and electric vehicle infrastructure. And beyond her technical work, Catarina is an advocate for diversity and future talent in engineering. She was the president of the International Institute of Refrigeration's Career in Refrigeration Working Group for over 6 years and plays a key role in promoting women and early career professionals through the IIR. Catarina, welcome again to the show and thank you for joining us on the special World Refrigeration Day episode.
Now, thanks for the invitation, David.
Pleasure. So we like to kick off with some yes-nos. These require yes-no answers if you possibly can. Is refrigeration one of the most overlooked contributors to global greenhouse gas emissions?
Yes.
Can innovation in refrigeration significantly accelerate progress towards net zero targets?
Yes.
Are we currently underutilizing thermal storage in commercial cooling systems?
Yes.
Is the UK doing enough to develop the next generation of refrigeration engineers?
No.
Thank goodness for that. I thought we were going to have a full house. 5, could better integration of refrigeration with energy systems like heat networks and renewables unlock major efficiencies?
Yes.
Great. You're the first person I think who's managed to not go, maybe not sure. So congratulations. So we always like to find out, how did you end up here today? I mean, how did you choose this particular career? What drew you to engineering and refrigeration in particular?
Okay. Well, I think my answer might not be exactly what you're expecting. So let me explain. So I always been keen to learn about how the world works, how everything works, really. So I was initially more attracted to science rather than engineering. But I ended up pursuing engineering because I actually, at the time, I didn't have the grades to go into a science degree, the one that was in my mind at the time. So I studied food science and engineering instead. And it turned out to be a really good decision. So it opened up opportunities for traveling, which is actually one of my passions. So I went to Germany through the Erasmus program, and then I came to the UK in 2006. And this was through the Leonardo da Vinci program. So this is like a European program for recent graduates to do a placement abroad. So my placement was at Bristol University. So this was how I ended up in refrigeration, because the placement was in the Food Refrigeration and Process Engineering Research Center. So this was my introduction to refrigeration. And then from there, I've moved to Odanda to work as a testing engineer. So I found out about the job while I was still at Bristol. And at Adanda, the work as a testing engineer was a bit about, testing their professional refrigerators at different climate classes, converting the system to use hydrocarbons, engineering changes, developing new products. And, I still remember coming to work every day, really excited just to analyze the data on the refrigerator performance, just to see whether, the experiment I set out the day before worked. I wanted to see if my theory was right. And, this is a profession I've grown to love, really. And even though as a teenager, wouldn't have never crossed my mind to work in refrigeration.
How many people answer that question in engineering? I didn't start here, but now I love it. World Refrigeration Day, it shines a spotlight on the vital role of cooling in modern life. What does this mean to you personally and professionally, and how do you think it's helping to raise awareness of the sector's importance?
So World Refrigeration Day really celebrates our profession, and it raises the awareness through social media. So it really is a great initiative, and I'm always happy to participate any way I can. So in the past, I've done webinars and now these podcasts. So obviously, always want to be involved. But personally, I think it's really important to raise the profile of our industry. It's becoming more and more important because temperatures are rising due to climate change, and the demand for cooling is going to increase significantly in the future. So, World Refrigeration Day is also an opportunity to showcase, what refrigeration involves every day. And also is, we are tackling climate change problems head on. And this is something that's really attractive to the young generation. And in a way, we kind of need to rebrand the industry in that light, because that would attract more people.
Yeah, I think that with that, it's one of the fastest growing industries in the world, isn't it? Particularly air conditioning. But with that comes a huge responsibility, doesn't it? In that, where countries are experiencing quite prolonged periods of, say, 40 degrees C plus temperatures, life becomes impossible without air conditioning, doesn't it? And how do you preserve food and things like that? So there comes a huge responsibility as well as, opportunity.
Absolutely. And also, you need to preserve vaccines, medical equipment, medical products. So it's the uses are everywhere, really.
Yeah. In your experience as project director of the TICR, is it the TICR project, or did you give it a fancy name?
We just call it TICA because it
stands. Okay, I thought you might. You're investigating greenhouse gas emissions in transport, industrial, commercial refrigeration. So, what were the key benchmarks and roadmaps emerging from your research?
So the TICA project is a consortium of 6 organizations, but we started by quantifying the greenhouse emissions from refrigeration in the UK. And we looked at several sectors. So we looked at transport refrigeration, we looked at food and drink manufacturing, chemicals and pharmaceuticals, data centers, which are growing at a fast pace, cold stores, and also supermarkets. So we looked at all these sectors individually, and we also carried out 50 site surveys. So the aim here was to identify, what's the current industry practice across all these sectors. And the findings are actually quite common among these sectors. So we then developed like a benchmark questionnaire. And the idea with this questionnaire is really to support businesses to identify how they are performing. So the questions relate to the best practice and opportunities for improving the refrigeration system, energy management. And really, we came up with the questions after doing the surveys and the research. So what we aim to do is to publish the benchmark questionnaire on our website, along with end user guidance, because I think the two kind of go together. So the website is netzerorefrigeration.uk, so quite an appropriate name. But this will be, right now we are just focusing on finishing the roadmaps. So with the roadmaps, what we did is we looked at the emissions and the energy use of refrigeration today, and then we looked at the impact of different scenarios all the way to 2050. So we looked at, how is the market going to grow? How is climate change going to impact refrigeration? And also because we found so many malpractices actually during the site surveys, we looked at actually there's a lot of potential to improve operations and maintenance. So let's try and quantify that effect. We also looked at what if you apply the best available technology within each of these sectors? Can you get to net zero? And what about if you go a bit beyond the system boundary and you look at integrating other technologies? And of course, we looked at using low GWP refrigerants so we can tackle Scope 1 emissions. So, briefly, in terms of the results, obviously market growth, climate change, they increase energy and emissions, but improving operations and maintenance, it can do that through better training and it needs to be done for the designers, for the engineers, the technicians, and the end users, really. It needs to be across the industry. There is quite a lot of impact. In terms of, best technologies, just some quick examples. We looked at electrifying transport, using liquid cooling in data centers, increasing the frozen food set points throughout the cold chain. So we looked at many different trends, many different technologies.
If you were looking at, the commercial built environment, but was there one thing that if you were all powerful, you'd say, if we did this, it would have the biggest impact?
It kind of depended a bit about which sector you went about. So for data centers was definitely liquid cooling was the big thing. For transport was really electrification. And for the other sectors, a lot of the potential was from integrating PV, integrating waste heat recovery. So there is a lot of opportunities.
Yeah, thank you. Having worked both in academia and industry, how do you see collaboration unlocking innovation in refrigeration?
Collaboration is really key. So I've worked at Dundee for 12 years. So I was in industry for quite a while. But, collaboration is fundamental to make sure you have access to the best expertise and to develop new ideas. For instance, Dundee was very focused on developing and patenting new technology. Which is, I think, relatively unusual because refrigeration is a very cost-driven sector. So collaboration can unlock untapped potential here. And just an example from another project, from the Green Skies project, we looked at integrating technologies, across heating, power, transport. So in the team, we had people with expertise on district heating, on electric vehicles, but also on business models and on community engagement. And really it was this multidisciplinarity that made the project so successful. So now just reverse it and imagine you can apply the same principle to refrigeration. It can really accelerate, deployment of new technology.
And we touched on it at the beginning about skills in the sector. And given you've got roles in the Institute of Refrigeration and IMechE, where do you see workforce gaps in refrigeration and cooling, and how can you attract a more diverse talent pool into the sector?
Yeah, that's a complex question to answer, actually. But just for a bit of context, so at the IOR, I was member of the Papers and Publications Committee. I'm a member of it. I'm also a member of the Women in RSC HP working group. And at IMECI, I'm in the Food and Drink Committee and also in the Decarbonization of Heating and Cooling group. So I have actually, access to a whole range of people that work in the industry as well through these groups. And there is gaps in the workforce because the average age is very high. If you go to an Institute of Refrigeration annual dinner, you can see that the demographics, and there's a lot of people over 50. So we really need to attract the next generation of engineers. And, in terms of, when we do surveys and we ask people how they joined refrigeration, quite often the answer is it was because of a family member or a friend. So there is not really a very defined career path for all stages. So, for instance, for engineering, people come from all sorts of degrees. The most common are building services and mechanical engineering, but people come from all areas of engineering. But also, when they come through the apprenticeship route, there is challenges at NVQ level to get students to level 3. So one option that perhaps would help is training the trainer program, just improve the overall capacity in the country. And if you want to look at much earlier ages with school kids, the STEMazing program that takes engineers into schools with cool experiments, that's a good way to inspire kids to study engineering, and you're reaching them at a really early age. But for teenagers, career fairs are also a good option, a good time to engage with them. But I think we also need more role models, more people to go into the schools and talk about what they do and how a career in cooling is so full of possibilities and it's not all about, just using spanners. There's a lot more to it.
Indeed. Well, you've been involved in diversity programs as well, and the dinners you were talking about not only elderly but pretty much all male. How do we get more diversity into the industry, and what programs do you think are working well in this regard?
Let me talk a bit about some work we did. So this was with so we created the Careers in Refrigeration working group. This was with the International Institute of Refrigeration, but it was actually an idea from my friend Ina Colombo. So we did our PhD together at LSPU, and we always thought it was really difficult to meet people at conferences when you are a student. And we kind of needed an icebreaker. So this is how we developed this concept of speed networking. So the idea is that you put the students and the experts in the same room, sitting at the same table. They talk for 5 minutes, then the students move on to the next table, so that by the end of the session, they've met a lot of people. And the feedback that we get from these sessions is that is really good. I honestly don't know if it's the students or the experts, which are senior academics or professionals from the industry. I actually don't know which ones like it the most, but it's been really successful. So we've done over 10 events in 4 continents, and now this is like a feature of the Congress of Refrigeration. So that's been really successful. That's led to new job opportunities for the students. So it's been really good. But in terms of getting more women into cooling, into refrigeration, we wanted to know what's kind of the status. And so we did a survey, a worldwide survey, and this was in partnership with UNEP and the IAR. And we had more than 800 women responding to the survey, which has now been repeated again in South and North America. So this led to a new network, so the International Network of Women in Cooling. And what the network is doing is developing mentorship programs for women around the world. So it actually has had a lasting impact, and that was just based on the findings from this survey. I was really pleased to be involved with that.
That sounds great. In BESA, we have a next gen group, which encourages young engineers to network with each other, so they carry on sort of outside of conference and those areas. And there's CIBSE have Young Engineer Network, which is very successful. So I think these things are there, but it's making that first step, isn't it? That's the difficult bit. Once you've done it once, you have more confidence.
Yes, that's right.
But there we are. Smart low carbon cooling is becoming vital in almost all net zero strategies. What roles does digitization, things like sensors, controls, and data analysis play in helping to decarbonize these systems?
I think they will have a much bigger role in the future to decarbonize the refrigeration systems. I mean, what we found when we did the TICA site surveys is that the sites that were performing better, they had proactive refrigeration optimization. So they were comparing the performance against the digital twin, and those were the best sites, but they were actually a minority. The majority of the sites were not even submetering the energy use for refrigeration. So there's still big gaps out there. And sometimes the data existed, but it was not available for the technicians to use. So there's still many opportunities there because it can help identify when the systems are not operating properly, what components need to be replaced before the technician arrives, and you can schedule preventive maintenance just before a heat wave, for instance. There's so many more possibilities. And I think maybe there's a bit of opportunity for the refrigeration design engineers to work with the controller manufacturers as well, just to improve the logic, the software, to maximize performance. It's a bit of bringing all this knowledge together in a way.
Yeah, and then having the skills in order to identify what the trends are and where the opportunities are, I guess, for saving energy and saving cost and time, particularly where you have a skill shortage. You need to be able to do things efficiently, don't you? Not simply on a time basis.
Absolutely. But I think maybe artificial intelligence can help with that in the future, maybe streamline the options for the technicians. So that might be a way.
As long as it's not hallucinating in that process, I think we'll be okay. So looking ahead, what emerging technologies and innovations do you see? Is it things like natural refrigerants, thermal storage, heat recovery? What are those do you think will transform the industry in, say, by 2030?
I think all of these, natural refrigerants are definitely the way to reduce Scope 1 emissions. But if you use the best available technology, you integrate renewable power, adding PVs on supermarket roofs or on cold stores in the industry, that's relatively easy and can have a major impact. And if you couple that with thermal storage, with demand side response, with heat recovery, integrating heating and cooling in industrial processes, there is so many opportunities here. But all this kind of needs collaboration between industry, academia, and government, really, to ensure we maximize the benefits so that we reach the net zero target. So it's complex because there's so many moving parts, but it's all possible.
Yeah, I mean, is a bit ironic in the period where we have probably less engineers coming into the industry. Systems are getting more and more integrated and more complex, and at the same time, we're in some ways trying to dumb down the training to make it into little bits. And what you've described is a world where actually, if you demand response, for example, you would have to have understanding of other bits of the industry to make that work. And you can't simply be responsible for one little bit because it is part of a holistic system.
Absolutely. Couldn't agree more. I think that's also what makes these sectors so interesting is all the skill set that's required, the multidisciplinarity around it. So it keeps you on your toes. You have to keep learning, really.
There's always great opportunity there, isn't there? So that's the end of my questions. And at this point, I'm desperately going to try and summarize what we've discussed. And this is the point where you say, no, you've got this all wrong. But let's see if we can do this. So first of all, on World Refrigeration Day, refrigeration and air conditioning has never been more important and is increasingly important. It's a fast growing sector. And with that comes a huge responsibility for people's health and well-being in all parts of the world. In the studies that you've shown, there's lots of good practice, but there's also a lot of bad practice, which is the low-hanging fruit, shall we say, that if we were to improve things like maintenance standards, then actually things would get rapidly better at pretty low cost. We definitely need proper career paths for refrigeration and air conditioning engineers, and a more open approach to it, so we get greater diversity in our workforce. Technologies that may not necessarily be refrigeration related, like sensors and data collection technologies, really help to get the most out of refrigeration and air conditioning. And in the future, it will become part of a far more integrated, holistic approach. Have I captured most of this, I hope?
I think you did a very good job of it, indeed.
Do I pass? I get a tick in the box. Thank you. So that's it, I'm afraid. Final question is, which I always like to ask is, are you optimistic about the future or a pessimist?
I'm always optimistic. Can see the opportunities.
I absolutely knew you were going to say that, which is great. Dr. Catarina Marques, thank you very much for joining us on World Refrigeration Day. It's been a pleasure talking to you, and good luck in the future with your studies and research.
Likewise, my pleasure. Thank you, David.
Thank you.